different functions. We will start with coordinate system. Also called rectangular coordinate system, is used to locate objects. The coordinate system is made up of two lines that intersect at right angle. So this is the two lines. One line is right here and one line is here. The horizontal line is called the x-axis. So this is the x-axis, and the vertical line is called the y-axis. The point of intersection is the origin, or this is the point, it's called the origin, of course. Each point has two coordinates, x and y. So for example, if I choose this point, we're gonna see that first coordinates is always on the x-axis, and in that case is 4 and 1, 2, 3. So this coordinates has 4 and 3. We put coordinates always in parentheses. If we want this coordinates, so let's calculate 1, 2, 3, 4. So it would be -4 because it's to the left. Is to the left from the origin. And how high is it? 1, 2, 3, 4, 5, 6. So this coordinates of that point is -4 and 6. The x-axis and y-axis divide the coordinate plane into the 4 parts, call it the quadrants. So we have 4 quadrants. Quadrant number 1, quadrant number 2, quadrant number 3, and quadrant number 4. Quadrant means that this is the first quadrant, and we usually use Roman numerals to denote quadrant 1. This is the second quadrant, so this is number 2, number 3 is right here, and number 4, that's this quadrant. So we have example 1. In a coordinate system, plot the points, connect them with straight line, identify the figure if possible. So this is my x-axis, this is my y-axis, and let's plot the point. The first point is 3, 4. So we're going 1, 2, 3, and 1, 2, 3, 4 to the top. So the point is right here, 3, 4. This is 3, this is 4 to the top. The second point has coordinates -1, so from 0 we go 1, and then we go 1 and 2, so we are right here. The second point is right here, 1 and -2, and the third point has 0 left, right, and only 1 and 2 down. So -2 right here. Then we can connect the points with a straight line. And they ask us to identify the figure. So clearly this is a triangle. Example B. The same way, we need to plot the points and identify what we're getting. So let's do the first one, -4 and 2. If each one is 1, then we're going -4 to the left, 1, 2, 3, 4, and 2, 1, 2 up. So this is my first point, -4, 2. Then the second point is 0 left, right, and we're going 1, 2, 3, 4. So we are right here on the second point. Then the third point is -5 and -4. So we start at 0, 1, 2, 3, 4, 5, and -4, 1, 2, 3, 4. So we are right here. And the last point is 3, 0. So we're going 1, 2, 3, and 0. So we're gonna be right on the line, 0 up and down. We will connect the lines to see what geometric figure we are getting. So it seems to me that those two lines, this line and this line, is parallel. So we're getting trapezoid. If you have two parallel lines, we have trapezoid. Trapezoid. Part C, exactly the same way. Let's plot the points. Start from 0 and go 1 and 2, 0 up and down. So this is my first point, minus 2, 0. Here is 1, here is 1 as well. The second point is 0 to the left, right, and up 1, 2, 3, 4. So we are on the 2, 4 right here. Then we have point 2 and 2. So that would be there. And then we have point 0 and minus 2. So this point is 1, 2, 1, 2 up. And this point is 0 left and right, and 1, 2, minus 2. So now let's connect the points and see what we're getting. So this seems to me that the points, there is no right angle to have a rectangle, but it looks like we have a parallelogram. The sides are not equal, so it would be parallelogram. Parallelogram is looking like this. So this is like shifted the other way. So it's parallelogram. Now we can move to the function. Definition of the function. A function is a rule that assigns to each x in its domain one and only one element in the range. So the first set, when we start, this is each element has one element going to the second set, which is the range. This element has only one, even though this element also go to the same one, but each and every one has one, so it is a function. A function can be represented in many different ways. For example, a function can be represented by a set of ordered pairs. We have 1 is assigned 2, 2 assigned 4, 3 assigned 6, 4 assigned 8. So each different x has different output. It can have the same, but we cannot have two the same ones with a different output. A function can also be given by the table. That table can be horizontal. This is my axis that assign the value of y's, or we can have axis. This is input x, output, or we can put it vertically, those ones this way. So of course, this is my x and this is my y. This table is not a function. Why? Because we have the same input 4 and has two different outputs. So one input can have one and only one output. And in this case, the same x has two different outputs, so not a function. A function can also be given by a graph. So this is a graph of one function. Or a function can be given by a formula, and a formula, for example, like this. The first, if we would like to find some points, we would have the values of x, and the value of y we would calculate 2x squared plus 3. So now the first value we choosing 0 or minus 1, 0, and 1. So because we're choosing the first value that we want, so let's call it independent variable because we can choose it freely. But the second variable we need to calculate according to the formula. So let's call it dependent variable. This number of y gonna depends on the number of x. So in that case, my y is gonna be 2 times, and I take this -1. I take this -1 and substitute here for x. So it's gonna be -1 squared plus 3. So if we perform this, -1 squared is 1 times 2 is 2 plus 3 is 5. And the same value of 0. We take the 0 value, we substitute for x. So we have 2 times 0 plus 3. So we have 2 times 0 squared plus 3. The value would be 3. And then we have y is equal for the last one, 2 times 1 squared plus 3. The value would be 5 as well. So for each given function, find the following. If you had these values, find f at 2, f at 0, f at 1. So exactly the same as we were doing. We have part A. F of x is equal to 2x squared minus 1. I hope everyone see that this f of x we can also write as y. It's exactly the same. You can write either y or f of x, exactly the same. Now they ask us to find f at 2. So we're gonna go f at 2. So to the function, to my given function, instead of every x, we're gonna substitute the 2. So what we have is 2 times, we substitute 2 for every x, and then we have minus 1. To this function, instead of every x, now we're writing 2. That's the 2. And then we can calculate. 2 squared is 4, times 2 is 8, minus 1 is 7. Then we have f at 0. We have f at 0. So to the function of f, for every x, we substitute 0. So we would write that this is 2. Then we have 0 squared minus 1. 2. Then we have 0 squared. And then we have minus 1. 0 squared is 0, times 2 is 0, minus 1 is minus 1. And then we have f at minus 1 is equal to the function of f. We substitute for every x. We're gonna substitute minus 1. So what we have is 2 times minus 1 and square it minus 1. So 2 times, instead of this x, we substitute minus 1. So we have minus 1 squared is 1, times 2 is 2, minus 1, the value is 1. Part B. Now we have the function g at x is equal to 2x over x squared minus 1. And the first one we need to do g at minus 2. So g at minus 2, that's what we need to calculate. So for every x, we're gonna substitute minus 2. For every x, this is gonna be minus 2. This would be minus 2 as well. So we're gonna have 2 from the formula times minus 2. So this is my x is minus 2. Then we have x squared, which is also my minus 2. Minus 2 square it and minus 1. We can see that for every x we substitute the minus 2 and the rest we have as it was. So now we can calculate this. 2 times minus 2 is negative 4. Minus 2 squared is 4. Minus 1 is 3. So the value is So the value is negative 4. I'm sorry, the value is negative 4/3. Then we have g at 0, g at 0. So now for every x we substitute 0, because that's how we calculate g at 0, right? So we have 2 times, and my x is 0. This is my 0 that we substitute. And then we have 0 and square it minus 1. 2 times 0 is 0. 0 squared is 0 minus 1 is minus 1. 0 divided by minus 1 is 0. And the last value, we have g at 3. So we have g at 3. As before, to all the function g, everywhere where is x, we're gonna put 3. Everywhere where is x, we're gonna put 3. So we have 2, that's gonna be my 3. To every function of g, instead of x, we're gonna substitute 3. So we have 2, that's gonna be my 3, my 3. So we have 2 times, we substitute 3, then we're gonna have 3 squared minus 1. 2 times 3 is 6, 3 squared is 9, minus 1 is 8. And this we can reduce it. We can divide this by 2, divide this by 2. So we have it 3/4. So the final answer is 3/4. Example 3. A blue whale has a fleeing speed of about 9 meters per second. The equation for the distance traveled d in meters in a time t second is given 9d times t. Instead of d, we can write f at t also. That's exactly the same. Find the distance traveled by the blue whale in 11 seconds and in 20 seconds. So what we need to do is find this. First, you always try to identify 11 seconds, what variable is for me. In that case, it's my t. So we're gonna find f at 11. So we have f at t is equal 9 times t. Now f at 11 seconds would be 9 times 11. 9 times 11 is 99. So the distance travel is 99 meters in 11 seconds, of course. In 11 seconds, the whale travel 99 meters. And the part B for 20 seconds, so we do exactly the same. F at 20 would be, we substitute 9 times time 20. 9 times 20 is 180 meters. So in 20 seconds, the blue whale travels 180 meters. Example 4. A cell phone company charges a monthly fee of $45 plus 7 cents for every minute of international talk time. The total cost, C, as a function of the number of minutes, M, is given by this formula. What is the total cost for the month with 200 minutes? So 200 minutes is my M. So we take this 200, substitute for M. So my C at 200 will be equal, and we write 0.7 times my M is 200. So 0.07 times 200 plus 45. plus this 45. So if we type this all on calculator, we should get 59. So the cost is $59. Example 5. Sally's earnings from babysitting E are a function of a number of hours she works each. Earnings is a function. She charges a flat rate of $10 to get to the location. She charges flat rate of $10 to get to the location and $15 for every hour she works. So her earnings can be represented by this function. Part A, how much Sally earn if she works 4 hours? So 4 hours is my age. So we're gonna calculate the earning by substituting 4 for age. So for part A, we're gonna calculate the earnings, which is equal to 15 times the 4 hours plus 10. So we have 15 times the 4 hours plus 10. And if we type this on calculator, we should get 70. So she earns the $70 in 4 hours. Now, part B, how many hours does she need to work to get $100 in one location? So now $100 is my earning. So we substitute $100 for the earning and we're gonna solve it for age. So we're gonna have it 100 is equal to 15 times age plus 10. One more time, $100 is my earning, so we substitute right here. So we have 100 is equal to 15h plus 10, and then we need to solve it. So we subtract 10, so we have 90 is equal to 15h, and to isolate for h, we will divide by 15. So then we have that h is equal to 6 hours. So she needs to work 6 hours to earn $100 in one babysitting location. Example 8. The formula to convert Celsius to degrees Fahrenheit is given by this. F Fahrenheit, C Celsius is given by this. If the temperature is 20 degrees Celsius, what is the temperature in Fahrenheit? So we need to recognize that 20 is what letter in my formula. That 20 is my C for Celsius, right? So part A, C is 20, and we need to find it. So we're finding F is equal to 9/5 times 20 plus 32. One more time, F, we can write F at 20 if we want, or simply just F. So F is equal to 9/5. C, my C is 20, so we multiply times 20 plus 32. If I type all of that on calculator, I should get 68. So 20 degrees Celsius is 68 degrees in Fahrenheit. Now for part B, we need to pay attention. If the temperature reaches 101 Fahrenheit, what is the equivalent in Celsius? So now we have the Fahrenheit. That's what we're gonna substitute, 101 Fahrenheit, and we need to find the Celsius. Because this formula can be written as F is equal to 9/5 Celsius plus 32. So this formula can shortcut be written as F. So now my Fahrenheit is 101, and we need to solve it for Celsius. So we have it 101 is equal to 9/5 C plus 32. So that would be my part B. And to solve it, we would subtract 32, subtract 32. So we have 69 is equal to 9/5 C. And to solve it for C, we would divide by this. We would simply divide by 9/5, divide by 9/5, all multiply time its reciprocal, right? So we have that C is equal to, you can use calculator, make sure you put parentheses, or multiply 69 times, to divide by a fraction means multiply times its reciprocal, so it would be times 5/9, and that should give us 38.333. So approximately my C is equal to 38 degrees Celsius.